I decided to make my Mac data and project on Aroldis Chapman's fastest recorded pitch in the MLB. I chose this topic because I've played baseball since I was 3 and could barely see a 30-mile-an-hour pitch. I got all this data from Major League Baseball's official website. Since Chapman threw 105 miles per hour, I had to calculate the speed in meters per second in order to do the remainder of the calculations. So 105.1 miles per hour is equal to 46.98 meters per second. Then I calculated the distance from the pitching rubber to home plate. Aroldis Chapman is 6'4" with an arm's length of 3'2". This would make his release point 9 feet 6 inches closer to home plate. Home plate is 60 feet 6 inches away from the rubber, so by subtracting his release point from the distance, I got an approximate distance of 51 feet, or by the calculations seen, 15.545 meters. After all of this, I calculated how much time it would take for the baseball to reach home plate by dividing the distance by the velocity. It takes the baseball roughly 0.3309 seconds to reach home plate. To give you a reference, it takes 0.1 seconds to blink an eye. I then put the data into a table. Since the object's acceleration is negligible, the time intervals and average speed are all the same. This column shows the distance interval in meters, this column shows the time interval in seconds, and this interval shows the average speed in meters per second. I moved this data from the table onto a distance versus time graph where it shows the baseball moving at a constant speed. Then I made a speed versus distance graph where again shows the baseball moving at a constant speed for each time interval. This free body diagram shows all the forces acting on the baseball after it leaves Aroldis Chapman's hand. The red arrow is the velocity propelling the baseball forward. The pink arrow is the weight and the gravitational force on the baseball traveling through the air. The green arrow is the lift, and the blue arrow is the air resistance, which is negligible. However, if the ball were to travel a farther distance, air resistance and gravity would ultimately bring the ball to a stop.